In this video, we're going to talk about threading in Android. And first of all, what are threads? Threads are separate processes that run in a Java program. They allow units of work to execute nearly simultaneously and increase CPU utilization while processes are waiting. So what does that mean? Well, it takes some work to draw our user interface, and we know that. It also takes work to fetch data from the internet. It takes work to draw images. And so what we want to do is optimize our use of the CPU so that while it's waiting for the user to hit a button, we can be maybe saving some data in the background. Or while we're downloading data from the internet, we give the user a responsive user interface that maybe even allows the user to cancel a long-running operation. You've probably had experience with software in the past where you click a button, maybe you meant to click it, maybe you didn't mean to click it, and suddenly your user interface is entirely tied up and you want to cancel, but you can't. So what you do is you keep clicking and you keep clicking. And in Android, what that will do is that will give you an application not responding error or an application not responding message, and it will allow you the opportunity to close the application. Now, most people will consider this to be a quality issue in an application. And we know we have the infamous triangle where we have time, functionality, and quality. And one thing that we cannot compromise on is quality. We can pick any two things from that triangle, time, quality, or functionality, but one of the two should be quality. So we don't want to have application not responding. We want to have the application responsive to the user. We want specifically the user interface to be responsive to the user. Okay? So threading is kind of a double-edged sword. It's something tricky because it requires a lot of skill. Okay? It's not something where you can just download front page or expression web and start threading. You typically have to have a little bit of experience as a programmer to jump into threading. But that's good because that means that we have marketable skills. As programmers, we have marketable skills. So why thread? Well, you have to be honest with you. In Android version 2, you could do a lot of things on the UI thread. And the UI thread is the default thread where you're doing work. So if you're doing things in an activity, and that activity maybe calls a network resource or renders an image, all of that is happening on the UI thread. In Android 2, you were allowed to do things on the UI thread, but it was not a good idea because an application would lock up while it was waiting for one of these things to complete, and the user gets frustrated. In Android 4, you can't do everything on the UI thread. If you want to do a network call, you have to do it in a separate thread. Android 4 won't let you run a network call on the UI thread. It will crash the program. Okay, I don't recall the specific exception off the top of my head, but it's an exception that will crash the program. So we have to get into threading if we're going to do any kind of network operation. And we're going to do network operation if we're going to be integrating data, which is one of the ways that we add values with our Android applications. So why thread? Keep the UI separate from worker threads. When you're doing anything that's processor intensive, saving to disk or maybe rendering an image from disk, any kind of network resource should definitely be threaded. Anything that takes a long time. In our introductory video, I talked about the PlayInPlaces.com mobile search by color and how it will look at an image. An image could be thousands of pixels. It will look at those pixels and pick the colors from those pixels. And then it will rank those colors by frequency and show you the 10 most frequent, but then it will also filter out colors that we don't want to see, like green, which every plant has, and sky blue. Because a lot of times if you take a picture in a tree, the background is going to be the sky behind you. So these are things that are processor intensive. These are things that we want to put into a separate thread. Okay? Okay. So we have a couple of different types of threads. We have traditional Java threads, which is where you have a class name thread and you put all of the stuff you want to do in a run method. And then you start that thread. When you start that thread, it actually creates a new thread of control and then in that new thread it invokes the run method. We'll look at an example of this in just a moment. In Android, it makes life a little bit easier on us because we have this concept of an async task, which is something that was created for Android to make it easier for us to thread. The trick is not just threading, but the ability to bring back information from the thread when the thread is complete. Okay, so I'll give an example here. This is from the liveplantplaces.com. One of the things that we do in the plantplaces.com mobile is we want to keep a local copy of plants on the phone so that the phone can go to an offline mode if we are the phone can go to an offline mode if we don't have network connectivity, which could happen because maybe we're in an elevator in a cement building, or it could happen because we might be GPSing plants somewhere on another corner of the world that doesn't have cell coverage. So what we'll do when we fetch plants, what we're going to do is we're going to make a copy of the plants that we've received. Okay, we're going to make a copy of those, and we are going to here we go. I'm sorry, this is the line I want. We're going to make a copy of those plants. We're going to spawn a traditional Java-based fire and forget thread. What that means is we take this copy of plants, and I realize this syntax is a little bit goofy. This is from the live running application. Trust me, it does work. And then what we're going to do is we're going to create a new thread with a run method, and we're going to start that thread. Now, we don't need to hear back from this thread. Okay, we're just taking a copy of the search results we've received. We're saving them into the database. The UI doesn't need to get any response from that because we're just saving the plants locally so that we can access them later if we need to. If something goes wrong, no big deal. We'll get it next time around. Okay, every time we do a search, it's going to make this local copy of plants, and it's going to check the database. If the plant does not already exist in the database, it's going to add it to the database. So this isn't a mission critical method. It will save a local copy of the plants, but if something goes wrong, we're not going to worry about it. We'll get it the next time we do a search. Okay, so what I'm going to do then is I have a breakpoint set. Okay, we'll set a couple of breakpoints here. I'm going to set a breakpoint right on this cache plants method. We'll try to see if we can set one there. And now using the emulator, I'm going to do a search. So I click on Advanced Plant Search. And while the emulator is running, one of the reasons we want to have a local copy of these plants, okay? Well, we do want to have a remote copy because that's the master copy. And as plantplaces.com grows, we want to maintain a master copy, and we want all of our users to benefit from this master copy and get the new plants. But on the flip side, we also want a local copy of the plants on the Android device as well, because you'll see that my cursor is in an autocomplete text view. And autocomplete text views should be populated from a local copy of data, because every time I type a letter, it's going to filter down a list. Okay, and so every time I type a letter, it has to see which plants match. We don't want to do a network call every single time I type a letter. Instead, we want to rely on local data. So for example, if I type Eastern, and the emulator is a little bit slow, but you'll see that after I type about 3 letters, it's going to start giving me a drop down of plants that are potential matches. Okay, and actually for this one, it looks like I'm going to need to do genus. This isn't the most up-to-date code base. But I can start typing, for example, Cercis canadensis, which is a redbud. Okay, you see, as I type in CE, it starts to give me plants that potentially match that. So I'm going to type in CER, okay, CIS, which is Cercis is the genus for a redbud. Now, what's going to happen here is it's going to go out to plantplaces.com's Android JSON. One second, I'll bring this up. I'll show you exactly the query it's going to do online. Just one second. Okay, it's going to go to plantplaces.com. Okay, Perl mobile view plants JSON PL common. Actually, we're going to do genus equals Cercis. I might have to do common. I think it's going to do genus in this case. I don't recall. Yeah, genus is fine. Okay, Control U. And you see what it's going to do is it's going to give us, this is JSON here, it's going to give us a list of 12 plants that are in that genus called Cercis. And then what Plant Places Mobile is going to do is it's going to save those 12 plants locally. You might notice that when I start typing Cercis, it didn't find an exact match for that yet because I don't have local data for that yet. But watch this. I click search, and the next thing we should see is our debugger. Okay, next thing we should see is our debugger should pick this up. Sure enough, there we go. And here we are in the cache plants method. Okay, now here's something really cool. If you take a look over on the left, you see all the threads that are currently running in Plant Places Mobile. You see they're currently, the numbering's not exactly sequential, but you see there are about 8 or 9 threads running. Now watch this. What I'm going to do down here, I have the thread locally. I have the thread here that's going to save these plants into my local database. Okay, I'm going to choose F6, and watch, it's going to skip. Well, it's, oops, you know what? Sorry, I have to get focus here. 1 second. Okay, I'm going to choose F6 or step over, and watch what's going to happen. It's going to jump down to thread cache thread equals new thread. Okay, and then cache thread dot start. Now, by the way, I don't expect you to know any of this threading information I'm going through, threading and runnable, this traditional Java fire and forget. I just want to demonstrate to you what a thread is. So when you see this syntax, thread, cache thread, and all that, I don't expect you to know or be able to repeat this. But watch this, okay? When I choose F6, you see we currently have thread 1, 10, 9, 12, 13, 14, 16, 17. When I execute line 186, you're going to see another thread pop up here in this debug frame. Okay, so let me get focus again. And I'm going to choose boom and boom, and we should see a brand new thread appear here. And the brand new thread is thread 15. Okay, the brand new thread is this thread 15, which is the thread which is copying the data locally. So an interesting thing about Eclipse, it will allow me to debug multiple threads at the same time, which is good because threads can be running at the same time. Okay, threads can be running at the same time. So if you look now, my user interface is not going to be responsive. I can click all I want here. It's not going to be responsive because that thread is currently locked up. But as soon as I tell it to play, that thread's going to be responsive, and will probably, in a moment, come back with some live data. Okay, so we're switching views now. Okay, and take a look. The user interface is updated with live data, which is all of the plants that implement Cercis. Meanwhile, we still have this thread running in the background, which is saving all of those Cercis plants locally. So I can step through the thread that I spawned that is saving all of my Cercis plants locally. And you see what's going on here. It's saying, I don't yet have this plant in my local database. I'm going to save it locally. This is a background function that, doesn't need to wait on any user response because we're just saving the data locally. So this is a classic example of a fire and forget method. Just run it as a separate thread. Meanwhile, the user can continue to use our application. I just clicked on Cercis chinensis, the Chinese redbud. The user can continue to interact with the user interface. The user can continue to interact with our application while this background thread is saving our data. And we see now it's going to bring up the plant information for the Chinese redbud, while still in the background we're saving off that data into our local database. Okay, so background thread is saving data. Well, with any luck, we're still going to be bringing up the Cercis chinensis on the UI. Okay, I'm going to go ahead and let this play. I'm going to let my thread play through. Okay. And it looks like I have a few breakpoints there, but I'm going to go ahead and let the thread play through. Okay. And what we'll see is, sure enough, the while we were saving the data locally, the web view appeared with the Cercis chinensis, the Chinese redbud. And as I'm recording this video, I don't know when you're going to be watching it. You could be watching it months or years after I recorded it, but nonetheless, as I'm recording this video, we're getting out of, hopefully getting towards the end of what has been a very cold and snowy winter in Cincinnati, and the redbud is usually one of the first trees to go into bloom. So I'm getting a bit excited about watching this guy. That's usually what you see. When you see that, you know that winter has officially ended, and this is definitely quite a beautiful tree. So I'm going to navigate back a few pages, and we're going to take a look at the advanced search screen one more time. Might take just a moment again because I'm on the emulator. Might take just a moment, so I'm going to, well, maybe not too bad. Okay, back one more. Now I'm back to the search screen. We're going to see something interesting here. I'm going to type CER, and remember the last time I did this it had only 2 results, and Cercis was not one of those 2 results because I had not yet saved that data locally in the local database. And there we go. You see, Cercis now is a 3rd result that appears. Before we had only Celosia and Cercifera. Now Cercis is an additional result because we've saved those values to our local database using a separate thread. I'm also going to type in east, and you might remember when I typed east the first time we only had 1 result. Now if I type east, we should see eastern redbud appear, which is one of those plants that came down with the Cercis when I searched on Cercis. So in the autocomplete, if all works well here, we should see eastern redbud. And again, this would be much faster. This will be much faster on an actual device than the emulator. Now, we didn't yet talk about how to handle the database. I think the emulator's falling a little bit behind. It still has my last drop down. There we go, Eastern Redbud. So you see now Eastern Redbud appears where that didn't appear earlier. Now, we haven't yet talked about how to handle actually saving to a local database or how to put together that database in this sequence of videos. If that is something of interest to you, I have several videos that talk about SQLite. Just send me an email if you're in either the University of Cincinnati or Northwestern University classes, or if you're not, simply add a comment to this video, and I will be happy to point you to those videos that talk about SQLite and how to handle that in a separate thread. Or to be honest, just search my channel for SQLite and you'll see the videos there. So this is an introduction to threading, and again, I don't expect you to know all the syntax, but some of the main points are that while debugging, we have the threads that appear over in the left, so we can watch the different threads that are happening. We know that we want to minimize the work we do on the user interface thread so that we can keep the thread responsive. In a traditional fire and forget thread, we will put all our work in a method called run, and then we will actually start a new thread, which will give us a new line here, by invoking the method called start. So these threads that we've talked about so far in this cache plants method are Java all-purpose threads. What we'll talk about in our next video is an async task, which is threading designed specifically for Android, and it's a little bit easier because it helps coordinate what happens in a separate thread with what happens on the UI thread, which is where with traditional Java threads it's definitely doable. It's just tricky. Android makes it easier with this thing called async task. But to talk about async task, we have to know a little bit about threading, which is this video, and we have to know a little bit about generics, which was our last video, and it helps to know about variable type and object type, which was also our last video. So all of this is building together into a discussion of async task. Once we cover async task, then we can make network calls. Once we make network calls, then we can fetch JSON data, we can parse that data, and we can make an Android app that creates value by integrating different pieces of data together. So, thanks for continuing with this journey. I look forward to seeing where this journey is going to end up when we go through our next few videos, and I'm really excited to see the kind of apps that you're going to make with these videos. Thanks again.